As I was going over Cork and Kerry Mountain to meet with Captain Farrell and the money he's accounted. First produced me pistol, then produced me rapier. Said stand and deliver, oh, the devil he may think you must sharing. We're for my daddy-o, we're for my daddy-o, there's whiskey in the jar. Hi there, mateys. Yes, today we're going to get jiggy with Ziggy. Motherfucker! So today we're going to get jiggy with Ziggy. And if you don't know who Ziggy is, Ziggy is actually a lizard. It's the logo of the Zig programming language, which is led by Andrew Kelly. And with a name like Kelly, ending on EY, you must be Irish. Imagine my fucking shock when I found out that he is actually a fucking American. But I mean, greater things have happened when American and Irish cultures came together. A prime example, the Boston Police Department. It's not like there's any corruption there, and that it is no fraud. It's really pinnacle of policing. But anyways, we're going to create the SMAC problem in Zig today, and we're going to create 3 versions: a single threaded version, a multi-threaded version, which is not going to be a lot faster because this is not really a challenging parallel problem. And then we're going to create one version that is actually a net version that you can telnet into and get that list of 1,000,000 entries with the SMAC problem. Now, if you don't know what the SMAC problem is, it's basically Fizzbuzz. It's a game that we played when we were wee little leprechauns on the playground. And basically it comes down, you're not allowed to say any number that ends on 7 or is a multiple of 7. Instead you say SMAC. And for you British, Irish, American toughs, if you don't know what SMAC is basically spam. It's a Dutch spam. And any meat product that has a lifespan of more than 3 years, you must be very careful with. This stuff is not good for you and it tastes horrible. Except when I found out, if you cut it in slices and then you bake it on a frying pan with some onions on there, some potatoes, Irish potatoes, and a little bit of ketchup. That is really, really great. So let's jump in and have some fun with Ziggy, and let's lose this accent. It's kind of difficult. As I was going over Cork and Kerry Mountains to program in Zig language. So first we need to install Zig. We go to ziglang.org, download, and you can download a tiny little binary, like 80 megabytes. That is really tiny, or even better, in case of Apple, we type in brew install Zig. You gotta love homebrew, right? Guinness is homebrew, or used to be, some very long time ago. So me homebrew finally brewing me Guinness, so now we're ready. Updated a whole lot. Let's create a folder here, src. Alright, let's create a file, smac_st.zig. I didn't install the language processor, and I'm going to switch to my normal accent, and that's already terrible enough, right? Okay, so with Zig, we first need to import the standard library. Now, the vision of the standard library is to be as small and efficient as possible. And that's something that I really like, but that brings one caveat: you don't really have any string functions. Now, obviously, you can import your standard lib from C and use those, or even your string libraries, because it's interoperable with C code. But we're not going to deal with any C. It's native Zig, just like the Zig standard libraries. And let's also create a nice little standard out that we import the standard.io .get what was it called again? Standard out. I hope that this is the right capits. And there we go, in the writer. Now I love this because it's very akin to JavaScript and TypeScript. You have sort of a very lean namespace now, and namespace was something we did not have in C. So that is really what I like. You can rename this any way that you want. Let's create a public function main, and we're going to return a void, but we're going to add an exclamation mark here because we need to propagate the errors up, because we're not going to handle errors. So we want the error to bubble up all the way to main. The errors is not really standard exceptions. It's more like the Rust, where you have an OK result and an error result. Right, so now we need to create a nice big list that we can hold the whole text of all the 1 million entries of the SMAC game. So for big list, let's call it that, equals, and we're going to use the standard library for the first time and import array list, which is basically a vector you could compare it to. And we're going to use type U8 because it's a list that just contains characters. And we're going to init it with the standard, in this case I'm going to use the standard heap page allocator. There are a lot of different allocators. That is something that I really enjoy. For example, you can have a buffer allocator. So if you create your own buffer that you can allocate it inside in, it's really cool. So have a look at these allocators. And yeah, a good C developer would immediately go to the end of the scope and do a free big list. We have a nice little trick here. We can defer this, and the function that is run after the defer is run as soon as you get out of the scope. You also have an error defer, which is really cool. That will run error defer, I believe. Error defer, yeah. That will run when there is an error. So during the error, you can free up your stuff. That makes it a lot easier to manage. So we're just going to call the big list dot the init function that will free the list when we leave the scope. And now we're going to get into a for loop, because we need to iterate from 1 to a million and one. And this is where I ran into a little problem when I just did the first take. I have the newest version here now on my Mac, that Guinness Brown for me. And that version broke the for one dot dot this type that I used in my code before. And as you see, when I save, it actually starts to complain, hey, there is an error. Oh, why? Oh, we're missing these. But yeah, it's, you see it complained, and I'm like, oh shit, I really love this new syntax. For some reason they removed it again, I don't know why. So we're using the standard documented syntax, which is using while loops, which I'm not really a fan of. It's a bit convoluted, but hey, it works, and it's the way that you do it in assembly. But I hope, Andrew, please, just bring them back. I love that for loop this way with the range. So we don't need to use the fucking while. That is just not right. Just doesn't feel right. So while index is less than 1,000,001, because that is not included. 1, 2, 3, 4, 5, 6. Yes, all right, we're correct. And then we just do index plus is 1. You don't have the plus plus. This doesn't work. Also a bit of a shame, because I really like that syntax in C, but I can live with that. Okay, so now we're iterating from, a 1, not 0, 1 to 1,000,001. So 1 million steps. All right, I hate it when I save that it does my brackets. And now we need to implement the algorithm. So with SMAC, we have a 1, 2, 3, 4, 5, 6, and then SMAC, because everything that is a multiple of 7, but also something that ends on, for example, 76, comma, SMAC. So that ends on the 7. This is not a multiple. Then we need to say SMAC. So that is very simple. If index modulo 10 equals 7, so if the remainder is 7, so for example in the case of 77, or, and we don't have this or like in C, but the keyword or. I'm fine with keywords. I'm more fine with keywords than using a while for a for loop. That's just wrong. Feels just wrong. %7, so if it's a multiple of 7, so 0, then we need to say SMAC, and else we need to say the number. So we're now going to add that in our list, and we do that with big list. This is kind of a cool interpretation. Writer dot print, and we can just use our string replacement. So it's a string and new, and we add the slice SMAC in there. Or we can do, let's do that for explanation purposes. Then we have two differences. Let's write SMAC and just do an empty list. That will work, and we need to do that. But this can cause an error. We may not have enough memory to allocate in the standard list, so it will cause an error, and we just quote unquote catch that with a try, so it will bubble up to the void to our console. And we're doing the same thing with the actual number, but then we do need to replace it, so we say D, and we put in the index, that is the actual number. All right, cool. And then we just want to print it. Now print, a standard print can also fill, and let's create a nice little function to do that. Print list, and we put in the pointer to the big list because we don't want to create a copy of a million items. So we don't need a public function for this. This is a private function to us. And we put in a list, and it's of the type pointer, just like in C, standard array list, and a U8. Alrighty. Okay, then we need to actually do something complex for a second, because this is just a list of characters, and we want to have the line. So we need to split on a line, and then we get an iterator, and we can then print that line to the screen. Although you could just do a whole print of this, but that would defeat the purpose of the instruction video. So let's do that. Let's create an iterator that is done by the standard memory and split. And this was one of those instances that I had to actually read the code, because the documentation just had two parameters, and they added the type in there, which makes more sense in my opinion. And this code, the standard library, is really well written. It's worth just reading through it. I learned so much just reading through it during an evening. And yeah, we just split it on the new line. So then we have an iterator, and we can now loop over the iterator. So if iterator.next is not empty, then we just try, and we use our standard out to print, which is the whole string, but with a new carriage return line feed, because the carriage return line feed is, or only the carriage return is chumped up with the split. And so we need to pass in basically the item that we still need to catch, I see, because we did not catch the item from the iterator. All right. So let's save. Do we have an error? Of course we have an error. What does it say? Function list. There is an error here. Why is there an error there? Standard array list, capital A. Oh, yeah, we need to return a type. And it is type void. That should satisfy it. Yes, there you go. So new terminal. So let's go into the source. Zig build-exe. Then it will find out which platform you actually run on and make that binary. You can actually target as well. And say, for example, Windows. That target. And it will build for Windows. This building toolchain is just brilliant. It's even better than Rust's. And that is saying something, because Rust's is already really good. And SMAC ST, all right. And so now when we run it, let's do a more. Let's see if we're correct. 1, 2, 3, 4, 5, 6, SMAC. 8, 9, 10, 11, 12, 13. SMAC, yes. 15, 16. Yeah, this ends on a 7. SMAC. 21 is a multiple. Okay, that works. So this does that. But we can also make this multi-threaded. In this case, it really doesn't do a lot for performance. If anything, it will hamper it. Let's time how much this takes, because we're just going to print synchronously to the screen as well. Or actually, are we? Let's see. Maybe I will wing something for this one. But let's create it multi-threaded so that you know how to do that as well. So 7.4 seconds. Oh, let's do that. Okay, so let's make it multi-threaded. I'm going to hack some code in here in between. So first I need to make a constant. I call it X. Usually I do capital X, but yeah, whatever. I'm not feeling it today. For constants, capitals are usually a bit more logical. And then we need to have a thread pool that contains out of X threads, or an array of 4 threads, so standard thread. And we need to always define them. In this case, we don't really know yet, so we pass in undefined, and that will satisfy the compiler. Okay, so first we need to instantiate the threads. Let's create a var I of type unsigned 32. It starts at 0, while I is less than X, then I plus equals 1. So this way we can instantiate the 4 threads. Actually, we're not going to use the big list. We're going to use a list. We need 4 lists, so let's call this list. Because each thread needs to have its own list in order to actually perform nicely. And we're also going to undefine this because we're going to init it in the threads. This will make more sense. Because each thread, you don't want to wait or update the single list because you get race conditions. So we need 4 lists for the threads. All right, so in this we're going to say list I equals the new standard array list. Yep, u8 dot init dot. Let's make a namespace for that standard heap allocator. Heap alloc. That way we don't have such amount of code. Dot heap dot page allocate. Yes, thank you, that one. And just let us pass heap allocator in there. Heap alloc. Okie dokie. And we need to, of course, clean it out. So we use that defer on that. And we call the init. All right. So that will clean it up as soon as we get out of the scope. And we need to spawn the thread. So thread spawning can fail. So we need to prepend it with a try. Hence we have that exclamation mark. So it iterates up. Standard.thread.spawn. It's almost as simple as in Rust. Still have to look in what the first type is. I don't use it. Then the function call. And we call the function count it. And then, so I'm going to pass in I and the list pointer of I. And that should make it. Yes, it's going to complain because we have not yet created it. Why is this undefined error? It's an S dot. That should actually work. What am I doing wrong? I'm not assigning it. That should work. Yeah, all right. Let's implement that little thread function. That spawns a thread, and we called it count it, right? Yes, count it. There we go. Count it. And it is an ID that is of type U32. That's the thread ID. And list, that is a pointer of standard array list. Thank you. U8. And we bubble up an error, and we return void because it does everything in that list. So now we need, let's do an address, which is of type usize. That is still a remainder of my for loop that they mangled, but that should still work. If ID equals 3, then we need to add 1, because we want it 1 based and not 0 based. So then we have a var index, and we need to start at usize Susie usize equals the ID times, we're going to use for list, so 250,000, because we want to iterate to 1,000,000, right? I'm winging this because I did not update that code yet. Usually I have them printed out and do it, and I'm just flying on with the seat of my pants here now. So if index is smaller than the ID times 250,000, and the great thing is you can actually use underscores in Zig. I really dig that. And then we need to add another 250,000 to it to get to the next, plus the offset other, otherwise we're off by 1, missing 1. And then the index plus equals 1, right? And then we implement the logic. So if index is 0, then we just need to continue, otherwise we have a division by 0. And otherwise, let's copy the code from the other one, because that algorithm remains exactly the same. Continue. What? Typo? Why don't you see that? Continue. Oh, he did see it. Okie dokie. Index equals. There should be a white space. Yeah, that is really, it's really finicky about that. All right, yeah. And we have the print list that we just, we can still use, because we can just pass in, yeah, the print list. So instead of printing the big list here, we're not creating a big list. We need to iterate over the threads. And we did not join them, so we can actually continue straight on. Let's remove this stuff. We don't need that here, so we can just iterate again. So I equals 0. While, oh really, I want my for loop back. While x, then I plus equals 1. Will it actually do the spaces for me automatically? While I less than x. Okay, yeah, it does. And here we're going to join to the thread. And immediately afterwards, when that thread is stopped, because it will first start the thread of the 0 to 250,000, or 1 to 250,000. So that should actually, last famous words, get in order. I think it will. And otherwise, we have a race condition. We can join all 4 threads and wait for it. But I think this will actually work. And then we will call our print list function. And we just pass in our partial list, the pointer to the partial list, I1. That should work. And to immediately free the memory, because we have 250,000, we can actually call clear and free, which clears that list and frees it automatically. And Zig will prevent double freeze, so that's kind of cool. So let's see. I literally improvised this. Zig build XC SMAC MT. Oh, of course there is a. Oh, we don't have a big list. Where did we have list? Actually, we cannot defer them here because we defer them there. Yeah, that should make sense. Try STD. Where is my sexual transmitted disease? What did you do? Line 34. 34. Well, line 14. STD. Yes, and then we have an undeclared identifier big list. Yes, it's called list, of course. Because we're... Alright, now it should compile. It does. SMAC MT. Will it start with the first one? 1, 2, 3, 4, 5. Yes, okay. SMAC 13, 14, 15, 16, 17. Correct. 21. Yeah, alright. Awesome, cool. So let's run it in the time. Now this probably will not be speeding up because the actual algorithm where we do the thread work, it's not really heavy enough. 736 and the other one, the ST, was something like similar, right? Because it's the printing that really slows this down, and that's basically a single thread task. 729, yeah, so doesn't really matter in speed, but hey, it gives an example how easy multi-threaded programming is. Oh, 6.7. Not really worth the complexity, but it gives an example. Now you can jump to the conclusion. I would advise you because there's some funny shit in there. Or we can actually do something that I also did. Implement the net version that you can telnet to the single threaded version, and it will print the list over telnet. Okay, let's quickly change this one into a net version. So I copied the ST to st.net. And first we need to import, of course, the standard net. Let's put it in namespace net, standard net. Then we don't need to type as much, which you probably like. We're still going to fill the big list. Yes, we're not going to do this exactly. Instead, we're going to create a server. Server equals net.stream server. It's actually a streaming socket. So that's kind of cool. .init, and we don't pass any constructor variables, right? I do want to actually make my server reuse the socket, because if the server ends and there is still client sockets waiting to close, you get an address already in use. And this will prevent that. This is something that I deduced from the standard reuse, from reading the standard.net code, because it's not yet documented. And just be a good boy, even though we're never going to exit this until we crash or close the server. But let's do a defer and the init on the server. Right, we need to try to bind a listen on the server. We need to .add address, and we need to parse the IP, because I'm actually going to put in an IP address here, which is 000, bind on all network interface cards, port 7979. Right, and we will never come here. So we need to catch the error and put it to unreachable. That will satisfy the compiler, something that I had to look into a little. Let's do a standard out and print listening on, and then the IP address and socket, or IP address, new line, that's kind of nice, right? Comma, and that is server dot listen address. All right. And now we go into a loop to accept. So we created a listener, and we bound that. That is all done in the listener. We don't need to bind it separately. And then we need to accept the client sockets. We're going to be very quick and dirty here. We're just going to pass a client socket to its own thread. So we still can have concurrent clients connect, but just, yeah, that is a recipe for a DOS attack. Usually you would have a thread pool with a number of threads or use an async. And they're currently actually implementing async keyword, which makes it a bit nicer. I decided to go now with the thread route because it's quicker. But there is already async functionality in it. So we're going to create a thread just like we did before. Thread spawn. We're not going to pass any constructor parameters, but we're going to do the print list. Yes, we pass the print list, and we need to pass in two parameters now. A pointer to the big list, because we don't want a copy of 1,000,000 records, and that connection. And the connection I do want a copy of, because if I pass that pointer, oh, and we need to create that connection. If I pass the pointer of the connection, the next client that attaches will then that be the pointer. So hence we do a copy. That way it's safer. Try server dot accept. That will accept the client socket. Accept. All right. All right. So there we have that big list. Now we're going to pass in here the connection, which is of type net.stream server.connection. And actually I'm going to cheat a little here. I'm going to add a pipeline, because when we have to send write, we are not allowed to actually use a print on that for some reason. And otherwise it's a bit of a hassle, so I just split on this, and then we still have that nice little new line. And that is faster than calling two writes. One for the data, for the item, and one for the new line. Try con dot stream and write, and then item, and we still have an error where 27. Oh, that should be in try. All right. Let's open a new terminal. Let's Ziggy build it. Zig build XC SMAC single-threaded. Well, technically it's not single-threaded anymore, but and the net version .zig. Oh, I need to go to the directory. All right. Oh, it's actually compiling first time. Seriously? SD, and then the net version. And of course we have an error. There's always an error. Why address in use? I do. Oh, I still have it running from the first time? Probably, yeah. Because I did a first take, but I tripped up on my words. There we go. And there we have it. Yes. And we can still telnet to it. Yes, that's one section. So yeah, we have one issue. We're not closing the socket. See that? So we need to do a con dot stream dot close. Let's do this. Let's build it again. See, that is the reuse that automatically binds it. And we have double sockets that we can connect. Awesome. And it does the same thing. So that is how easy it is to create socket servers. Yeah, I love myself a great jig, and Zig is an awesome jig. I'm very, very impressed. And to me, programming in Zig was like encountering an old friend, getting a warm, comfortable hug, and then looking up on his face and go like, "Dude, you had plastic surgery. That is such an improvement. Don't change." And what I really adore about the vision of Andrew Kelly is to keep the standard library small and fast. And it is fast. Recently on Dave's Garage, Zig was #1 on his PrimeShift drag race with incredible numbers. So I think Zig has a bright future, especially in low level and microcontroller development, and Rust on a C++ and Java replacement side. So 2 incredible, awesome, compiled system all-purpose languages that are now happening. I think Carbon, Google, just stop Carbon. You're a bit late to the drag race. Zig is already there, Rust is there, there's no reason for another one. So yeah, incredible times. I hope you learned something, and I hope to see you in the next one. And I will be playing a little bit more mandolin.